So in this lecture, we'll be looking at the notebook to demonstrate NMF. Note that the format of this notebook will be very similar to LDA, so we'll go through most of it fairly quickly. As before, we'll begin by downloading the BBC News dataset. The next step is to do our imports. Note that this time we'll be using NMF with TF-IDF. So why is it okay to use TF-IDF with NMF? As you recall, the reason we use simple counts with LDA is because that it corresponds with the multinomial distribution, which is part of the LDA model. The next step is to download our stopwords. The next step is to convert our list of stopwords into a set. The next step is to add additional stopwords. The next step is to load in our data using pd.readcsv. The next step is to remind ourselves what this data looks like. The next step is to create our TF-IDF vectorizer object, passing in the stopwords we defined above. The next step is to transform our text into a TF-IDF matrix. The next step is to create our NMF object. Again, we'll choose 10 components. Note that for the loss, we'll use the KL divergence, which, when you do, corresponds with probabilistic latent semantic analysis. Another way of looking at this is, the paper on probabilistic latent semantic analysis really just describes non-negative matrix factorization, with KL divergence as the loss. Note that when you use this loss, it's required that you specify the solver as MU, which stands for multiplicative update. Note that it's also possible to regularize the weights, but I've commented this out since it's not needed. Finally, note that I've set the random state to 0 so that we obtain a consistent results. The next step is to fit our model. The next step is to define the plot top words function once again. The next step is to call the plot top words function once again. Okay, so let's have a look at these topics to make sure that they make sense. So the top words for the first topic are people, UK, mobile, US, music, and so forth. So probably mobile technology is a good way to summarize this topic. The top words for the second topic are labor, election, Blair, party, and so forth. So clearly this is about politics. For topic 3, we have England, win, Wales, Ireland, injury, rugby, coach, and so forth. Clearly this is about sports, and specifically rugby. For topic 4, we have film, best, awards, and so forth. So this is entertainment. For topic 5, we have growth, economy, bank, and so forth. So this is economics. And again, check out all the other topics as an exercise. The next step is to transform our data to get back the documents by topics matrix. The next step is to plot the topics for a randomly chosen input sample. As you can see, the true label is sport, and the strongest topic is topic 3. By the way, note that unlike LDA, these values do not sum to 1. So let's scroll back up and remind ourselves what topic 3 represents. Okay, so topic 3 is related to sports, and specifically rugby. So let's print out this article to make sure that our topic makes sense. So the article is Charvis set to lose fitness bid. So these results make perfect sense since Charvis is in fact a former rugby player.